Greetings, engineers, and welcome to the Rivers Air and Space Program, aka RASP. I'm going to be introducing you to our new project that we will be undertaking over the next 2 months. Our objective is to collect bird's eye video data from altitude of the Rivers campus via an inexpensive, reusable, and portable launch system. Management has already made some decisions about the system and what components it should use. We've decided on a water-based rocket system, as it will be inexpensive and safe to use. We will be using inexpensive, compact digital video cameras for not only the expense, but also because, given that we are using rockets, these things may crash during testing, and we don't want to have expensive equipment being ruined. Lastly, you're already familiar with the Arduino-based electronics package, which we will be using to control the rocket systems. The system starts on the ground with a launch platform. This will be constructed out of PVC pipe. Some of these launch platforms have already been built, and you will be working around those to add on mechanisms for the launch system. Connected to this will be a bicycle pump and a 2-liter water bottle, which will be filled with water. Once it's filled about 2/3 of the way, it will be placed on top of and attached to the launch system securely. On top of this, you will add your electronics payload. This will be attached securely during launch and will contain the Arduino electronics package and your digital video camera, along with all other necessary electronics. Once these are all installed and attached to the launch system, the 2-liter bottle will be inflated using the bicycle pump. The rocket will then be released, causing it to launch into the air carrying the payload. When it reaches its maximum height, it should deploy a parachute, which will cause the rocket portion to separate from the payload. The payload should then descend slowly and safely while collecting video data. Once it is on the ground, it should stop collecting data and indicate that it is ready for retrieval. There are some additional considerations you should keep in mind while constructing your design. The system should overall be intuitive and reliable, meaning that anyone with minimal training should be able to use it. Additionally, we have limited numbers of some of the components, and some of them may end up being damaged during failed launches. To combat this, ease of repair and access should be a priority when you're making your design. Specifically, things like batteries, cameras, and electronics boards should be easy to take in and out in case you need to replace them, or in case we run out and you have to share with another group. Furthermore, thorough testing should be conducted before launching any delicate equipment. We don't want to damage anything on risky launches when we have such limited numbers. Your first assignment is to list out in as much detail as you can and as specifically as possible what the requirements for your system are. Here's an example. Your launch system, the platform, and the rocket together need to be airtight. You will be pumping the rocket up to anywhere from 50 to 100 psi, and so the rocket needs to contain all of this pressure safely without leaking. Next class, you'll be placed with your group and you will begin making your design decisions. Good luck!